All right, so we are moving on to 1B.10 Intro to Piecewise Defined Functions. I don't know why it's so close with the 10 and the I, but pretend you don't see that. And so for this, how does this tie into average rate of change? Well, so you remember how when we were doing average rate of change, we talked about intervals, correct? And how on each interval, each piece of the situation was behaving differently, correct? Well, when you put that all together, those are called piecewise defined functions. That's because you're taking little pieces and you're putting them together based on different intervals of things that are taking place. Does that make sense? Okay, that's why it's called a piecewise defined. So, with that being said, we're going to dive a little deeper into um, two piecewise. So, I don't know. I mean, I know that y'all have heard of Khan Academy, but I don't know if y'all like appreciate the sound of Dr. Khan's voice. I don't know. To me, Dr. Khan's voice is somewhat soothing. It may not be to you, but he seems like a guy that I can learn from. And that I'm like, oh man, he's a really cool guy. So what we're gonna do is I'm going to let you watch. We're not watching the whole thing, but I'm going to let Dr. Khan introduce us to piecewise function. Okay. After he does his little introduction, we're not gonna watch the entire 3 minutes, but then I'm gonna lead into a little further. In Common Core, which is taught in other states and places, piecewise functions is introduced in Algebra 1. Okay, in the state of Texas, piecewise functions is not introduced in Algebra 1. Okay, so if you were to go look on Khan Academy, your intro to piecewise is usually probably under Algebra 1. And that's because in other places it's introduced in Algebra 1. But let me click here, open. Okay, I swear I opened this earlier just fine. There she goes.
By now, we're used to seeing functions defined like h of y is equal to y squared, or f of x is equal to the square root of x. But what we're now going to explore is functions that are defined piece by piece over different intervals. And functions like this you'll sometimes view them as a piecewise, or these types of function definitions, they might be called a piecewise function definition. And so let's take a look at this graph right over here. This graph, you can see that the function is constant over this interval for x, and then it jumps up to in this interval for x, and then it jumps back down for this interval for x. So let's think about how we would write this using our function notation. So if we say that this right over here is the x-axis, and if this is the y is equal to f of x axis, then let's see, our function f of x is going to be equal to, let's see, there's 3 different intervals. So let me give myself some space for the 3 different intervals. Now this first interval is from not including -9. I have this open circle here, not a closed-in circle. So not including -9, but x being greater than -9 and all the way up to and including -5. So I could write that as -9 is less than x, less than or equal to -5. That's this interval. And what is the value of the function over this interval? Well, we see the value of the function is -9. It's a constant -9 over that interval. It's a little confusing because the value of the function is actually also the value of the lower bound on this interval right over here. And it's very important to look at that this says -9 is less than x, not less than or equal. If it was less than or equal, then the function would have been defined at x equals -9, but it's not. We have an open circle right over there. But now let's look at the next interval. The next interval is from x is greater, or -5 is less than x, which is less than or equal to -1. And over that interval, the function is equal to, the function is a constant 6. It jumps up here. Sometimes people call this a step function. It steps up. It looks like stairs to some degree. Now it's very important here that at x equals -5, for it to be defined only one place. Here it's defined by this part. It's only defined over here. And so that's why it's important that this isn't a -5 is less than or equal to, because then if you put -5 into the function, this thing would be filled in, and then the function would be defined to both places, and that's not cool for a function. It wouldn't be a function anymore. So it's very important that that when you input -5 in here, you know which of these intervals you are in. You can't be in 2 of these in two of these intervals. If you are in two of these intervals, the interval should give you the same value so that the function maps from one input to the same output. Now let's keep going. We have this last interval where we're going from -1, we're going from -1 to 9, from -1 to +9, and x, it starts off with -1 less than x, because we have an open circle right over here, and that's good because x equals -1 is defined up here, all the way to x is less than or equal to 9. And over that interval, what is the value of our function? Well, you see the value of our function is a constant -7. A constant -7.
Okay, so essentially when we were looking at our different various graphs, right, from the snow falling to the Super Bowl, do you see how we could have different pieces taking place and be able to describe what's happening on those intervals? Yes. So that's why it leads us into piecewise defined functions. Okay. And our goal here is to be able to create and interpret, and analyze a piecewise function. So we're going to thank you, Khan Academy and Dr. Khan, for your time. So we're going to dive in straightforward to like where we're at here. So this is a piecewise defined function. I chose this one because, do you guys remember when we watched the snowfall, right? Y'all remember the snowfall, Mr. Dude watching the snow? And we had those different curves on it. So we had a curve that was a negative parabola. We had a positive parabola. We had some type of curve that took place. We had a constant. We had a linear, right? Y'all remember it? I'm not crazy about the snow. So essentially, you can have multiple types of functions. They do not all have to be linear. When we looked at the Super Bowl, they were all what? Linear, right? All linear pieces. It was a line graph. But they do not have to be. So what we have here is our piecewise defined function. And in order to do this, we're going to have to evaluate what's happening at each endpoint. Okay, what's happening at each endpoint to know how it's acting on those at that given boundary or given interval. So when you look up here, let me my writing window. So when you look here, we have 2 minus x, 1 minus x squared, and x cubed. We have three different types of functions here. We have a linear, a quadratic, and a cubic function, right? Which means that they all are doing their own thing. Their behaviors are different, but they're only taking up certain parts of our graph. The only parts of the graph that we're taking up are from -3 to -2, -2 to 1, and 1 to 3, okay? What I call these are our boundary lines, right? You have your lower bounds and your upper bounds, your lower bound and your upper bound, lower and upper, okay? Next, we're going to notice that they're only defined in one, but not both. As Dr. Khan told us kindly, it cannot be defined in both locations, because if it's defined in both locations, then it's not a function, right? So notice here that it says it's strictly less than -2 on the first piece of the interval, but it is equal to on the second. It's equal to 1 here on the second interval, but it is strictly less than on the second. So no double definition or defining of our x's, because if it's a function, remember your x's do not repeat, okay? If my x's were to repeat, then it wouldn't be a function, okay? Are you still with me? So remember that. How do we know we're defined? If I am at less than or equal to or greater than or equal to, that is a closed circle. Do you remember those rules? Okay. If I'm strictly less than or strictly greater than, those are going to be our open circle, or undefined points. So in order to evaluate, you're going to choose, evaluating and graphing are different. When you're evaluating, you're only choosing which interval it's defined at to solve. When you are graphing, you have to test it at each interval. Does that make sense? Okay. So we're evaluating first, and then we're going to graph. So it says first evaluate -3, -2, 1, and 2. Okay. So first we're going to write it as f of -3. If I'm evaluating f of -3, I'm looking for which interval is -3 equal on. Is that going to be my interval 1, interval 2, or interval 3? 1. Interval number 1 is where -3 is defined at. That's where it's equal at. So that means I'm using the 2 minus x to evaluate. So I'm using 2 minus x to evaluate f of negative 3. So where there's an x, it's now going to become a negative 3. So this equals 2 minus negative 3. And that equals what? 5. So f of negative 3 is 5 for this function. Still good? Okay. Next, we're going to evaluate f of negative 2. So we're evaluating f of negative 2. Which interval is negative 2 defined on? And why is it at 2? Because it says equal to. It has the less than or equal to, right? That's where it's less than or equal to. So that means I'm taking the value of negative 2 and I'm inputting it into 1 minus x squared. So that gives us 1 minus negative 2 squared, which equals what? Negative 3. Negative 2 squared is positive 4. 1 minus 4 is negative 3. That is where it's defined. Make sense? Yes? Okay. All right, now we're going to do f of 1. So f of 1 is defined on which interval? It's also defined on interval 2 because that's where it's equal to, correct? So we're going to be plugging 1 into interval 2, which gives us 1 minus 1 squared, which is 0. Okay. Then we have f of 2. F of 2 is defined on what interval? 3. I am still baffled by this no writing zone. F of on 3, right? Because 2 is between 1 and 3, correct? So therefore I'm plugging in and that gives me 2 to the third, which equals 8. So that's how you use piecewise defined functions to evaluate. You determine where they exist, and then that's the rule you follow. Make sense? Yes? All right. Now let's talk about graphing them. So to graph, you're going to, I like to start off with identifying the breaking points, which are going to be your upper and lower bounds. Like, where is my pieces being broken? If you like to highlight them, go for it. I'm going to highlight up here. And I'm highlighting the points where my function breaks. So at negative 3, negative 2, negative 2, 1, and 3, those are all my breaking points. So I have 1, 2. Pretend that these are straight lines. We all know that for some reason I am challenged with drawing straight lines. Bless you. Negative 3. I'm also breaking at, yep, that's straight. Negative 2. We have a break at 1, and you have a break at, oh, that one's terrible. I can't even pretend. At, okay. Now for these points, you already have values that are already defined for them, correct? So we know where they're defined, meaning that we know where they're going to be closed circles at for each one. Make sense? So for negative 3, we know that it's defined at 5. So when I go to negative 3, I go to 5. I can go ahead and put in a little dot. It's closed. However, I do not know where it's undefined at, which is my negative 2. So to find this undefined location, we're going to take the value of our undefined bound, our upper bound here, and we're plugging that in. So we're plugging in negative 2 to figure out where is my hole at? Where's my undefined point? Does that make sense? So negative 2 plugged in gives me what? Someone said it? 4, right? 2 minus negative 2 is 4. So I know that when I go to negative 2, I'm going to go to 4, and it's a open circle. And I can piece that together, and that's my first piece of my inequality. Not my inequality, of my piecewise. In theory, I should be able to draw a straight line. In theory. All right, so first piece done. Now you're going to do the second piece. The second piece is a little easier because we were defined at both places, right? So we already know the value of its lower bound and the value of its upward bound. Is that correct? Yes. F of -2 is what? -3. And F of 1 is 0. So when I go to -2, and I'm going to go to -3, and I'm putting a closed circle because that's where it's defined. I go to F of 1, and I go to 0, and I'm putting a closed circle because that's where it's defined. And then I'm going to connect these 2 points. If you want to be like, really awesome and try to connect it perfectly, cool, do you. But I'm going to show you that you cannot just go like this. It's not a straight shot because this is a quadratic, right? Because it's a quadratic, I know that there has to be some type of curve in here. It's not connected. So this is where that using a little bit of math sits come into play. I'm going to check out what 0 is doing, right? And the reason why is because I can quickly plug in the value of 0. If I wanted to know, okay, what's happening at 0, I'm going to plug 0 in. When I plug 0 in, what do I get? 1. So I know that at 0, I have to go through 1. If I was to draw a straight line to connect here to here, would that take me through 1? No. So that gives me an idea of the fact that, okay, this has to be going up and then coming back down. Okay, that's where it comes into play of us making sure we understand what each shape of a function looks like, right? If I have to remember that a quadratic has a parabolic shape, right? It's a parabola. There's some type of curvature taking place. If I had drawn them together like a linear, would that have been correct? No. So keeping in mind those little things. All right, next. So now we're on x to the third. X to the third, we have not defined 1 or 3 because when we were evaluating, you only evaluate where you're defined at, right? And we were not defined at 1 and 3 for this interval. So we have to find those values. So we're going to look for, to graph, we need to find what is 1 on this interval. Well, what would a whole be on this interval? Well, I'll plug in 1. What is 1 cubed? 1. So I'm going to go here on 1, and I'm going to have a open circle. And I'm going to do my upper bound. I plug in 3. What is 3 cubed? 27. 27 is way off our page, right? So for 27, I'm just going to be like, oh, all the way up here, bro. It's an open circle. That doesn't even look open. But nonetheless, it's just to show that I'm going to have to go off the page. Does that make sense? So to connect them, it's going to be going something like and beyond. And that's your piecewise. Okay? You literally just do it in pieces. That is it. Okay? You evaluate and you graph. You evaluate, you graph. You evaluate, you graph. All right? All done in pieces. Are y'all ready to try? I think you are. All right. So here you have 0.5x squared if x is greater than or equal to -4, but less than or equal to -2. You have x if x is greater than -2, but less than 2. And you have x squared minus 4 if x is greater than or equal to 2, but less than or equal to 4. Okay? So you're going to graph the intervals. Remember, piece by piece. And all you're doing is plugging in your lower bound and your upper bound to figure out what they're doing on your breaking points. Yay, nay, maybe so. Maybe. Okay. I will say that for the graphing, if you want to adjust your counting because you're only using twos and fours, if this is too tiny, you can always decide to count by something different. Like you can be like, okay, I'm not using these numbers. I'm counting by twos now. Ignore my numbers. We're not counting here. If it's bothering you, so this would be my 1, this would be my 2, this would be my 3, this would be my 4. So if you feel like you need bigger spaces or however you want to do it, but the only way that it's going to start feeling somewhat comfortable is if you just try it. Okay. So my hint to you is, where are your breaking points? Where are your bounds? All right. So welcome back. Here we have our beginning. So, I went ahead and I decided to make my spaces a little bigger so that I'm counting and I can give myself a little space. So I'm starting with my first interval. My first interval, its lower bound is -4. So I'm going to substitute -4 in. -4 squared is positive 16. Half of 16 is 8. So I'm going to go to 8. So at -4, I'm going to 8. And it's going to be a closed circle because it's equal to. Did we see that? Okay. Now I'm going to do my upper bound, which is -2. I'm going to substitute -2 in for x. -2 squared is 4. Half of 4 is 2. And it's going to be closed circle because it is equal to. Yes? So I'm going to go to -2. And I'm going to go up to 2. And I'm going to put a closed circle. And I need to connect these two. I am a little anal, so I would probably try to still get through 4.5 because that's what it would be at 3, because 3 squared is 9 and half of that. So I'm going to just, and there's my curve-ish. Not a big curve, but it's a little curve. Okay, and now I'm going to do the next one. So on my next piece here, notice that they both are not equal to, so both ends should be open circles unless they're already defined. So I'm going to evaluate -2. Well, -2 at x is just -2. So I'm going to go to -2 and go down to -2, and I'm putting in open circle. And that's because it's not defined, it's not equal to, it's strictly less than. Now I'm going to go to 2, and again, it's just going to be 2 because the input is the same as the output. So at +2, I'm going to go up to 2, and it's going to be an open circle. And this is just a linear equation connecting these two. And that's my second interval. They both are open circles because it's not equal at those bounds, correct? All right, on the last one, I have a lower bound at 2 and upper bound at 4. So I'm going to substitute 2 in. At 2 squared, that gives me 4. 4 minus 4 is 0. So at 2 on this one, At 0, I'm going to be a closed circle. Why am I closed? It's equal to, I'm defined there, right? My upper bound is 4, so I'm going to plug in 4. 4 squared is 16, and 16 minus 4 is 12, right? So at 4, I would be a little bit off the page, and it would be a close, because again, I am equal to. And I'm going to create a little curve to connect these two guys. And bam, we're going to call it a day. And those are my 3 intervals of situations. Okay? Was it that bad? All it is still part of 1B.8, which is just evaluating, right? And then intervals coming from looking at different pieces, because our world works in intervals. And that's